Welcome to Get Sleepy, the podcast where we listen, we relax, and we get sleepy. As always, my name's Tom and I'm your host. Thanks so much for joining me here. Tonight we'll take an imaginary adventure into the future and gaze at our neighbouring planet, Mars, as it's being terraformed many years from now. So just get nicely settled into the coziness of your bed. Your head and neck gently supported by your pillow, and your body laying in whatever position feels best right now. Our otherworldly adventure tonight is full of imagination and futuristic possibilities. Some of my favourite conversations to have and to listen to are those that try to comprehend our frankly incomprehensible universe and what it all means for us as people. Of course, we don't know for sure just how rare or how common advanced civilizations like ours might be, but there's a pretty good chance we are one of very, very few, perhaps even the only one in our entire Milky Way galaxy. That might be a bit of a scary thought for some, or perhaps for others it could make life on Earth feel rather insignificant. But perhaps more than that, it gives reason to truly appreciate the fact that what we have here is incredibly precious. If we really are as rare as we think we might be, then I believe we should recognize the importance of protecting and sustaining our world and all the life on it. Because we might well be the very thing that brings meaning to an infinite universe. And that includes you, listening to my voice right now. We all tend to wonder, what is our purpose, our meaning in this life? Well, perhaps you in yourself are the meaning. The fact that you can comprehend such a thought is profoundly precious and rare in itself. So take a deep breath in, appreciating the life that the oxygen provides. And as you release it back out, relax further into bed and know just how meaningful you are. It's time to begin our adventure into the vast expanse of space. So settle down deep into rest and comfort. Our starship, the Orion, is about to take off. And this is where our story begins. We're currently awaiting departure from Phobos Orbital Station, circling the Martian moon. I am Asa, your autonomous suborbital assistant. On behalf of the Olympus Project, let me be the first to welcome you to Mars. You are among the first generation of terraforming technicians, scientists, and explorers to arrive. Your hard work, bravery, and curiosity will inspire those who live and work on Mars for generations to come. I'm so happy to show you your new home. Before we arrive at the Mount Elysium colony, I've been tasked with giving you an overview of the project to date. A monumental effort, unlike anything in human history, the Olympus project has spent centuries laying the groundwork for making Mars habitable. Magnetosphere engineering, orbital mirrors, and planet-wide biological seeding have built an atmosphere. It will be a while before the project is ready to house our Martian pioneers, but you'll be pleased to hear that simulations put the project ahead of schedule. Now, please make sure you're comfortable and settled in for the flight. All systems are green. We are now departing Phobos Orbital Station. Smaller transport ships, like the one you're in now, allow safe and efficient suborbital travel around the planet. As we enter the Martian atmosphere, you may feel a gentle rocking. If you need to readjust your position at any time, that's perfectly fine. This flight should be comfortable and pleasant for you. We have now entered the Martian atmosphere. From this altitude, you'll notice that Mars is still very much a red planet, though the Olympus project has introduced more colours to the palette. From here, you can see that the Martian terrain is unique. The northern hemisphere, in places, is several kilometres lower in elevation than the southern hemisphere. Much of the northern hemisphere, about a third of the entire planet, is like a large basin, relatively flat and featureless. The southern hemisphere is rocky, with significant mountain ranges and land masses. We call this hemispheric dichotomy. We're now hovering over the western coast of Elysium, which will eventually be the biggest island continent. You may notice that the water along the current shore is misting and ribboning. That's because the surface gravity of Mars is a fraction of Earth's, around 38%. While the Olympus project works to fine-tune the atmospheric conditions, water will jump around a little strangely. As the terraforming process continues, we are closely monitoring sea level and precipitation. But already, we have a growing blue-green ocean that covers most of the northern hemisphere. Let's fly over the area that was once Elysium Planitia, or the Elysium Plains. We now call this region the Elysium Channel. The green colour you saw from orbit is actually in the water, not on land. While we've seen a great deal of success with growing lichens, It's the algae that's contributing most to the success of early plant life. In the shallow waters of the channel, you can see it close to the surface, hoping to get some of the sunlight that reaches Mars. From this distance, the sun isn't nearly as bright as it would be if seen from Earth. Now that we've gained some altitude, look to the north, toward the island continent of Elysium. Mount Elysium is an active volcanic region, about 1.5 times the height of Mount Everest back on Earth. From here, you can see it has a distinctly mound-like shape, much wider than it is tall. At the top is the caldera, a ring about 14 kilometers in diameter, almost 9 miles, with 2 smaller volcanoes to the north and south. Further to the south is the Channel, and to the north you'll find the Sea of Utopia. The Olympus project honors the legacy of early space exploration, so this name is borrowed from Utopia Planitia, the Utopia Plains. At this distance, with blue-green water lapping at the rocky, ruby-red shore, we can imagine the way all of these changes will continue to affect Mars. This is a planet with highly variable temperatures and dusty winds. Things will change a great deal as we establish a habitable atmosphere and see more diverse weather systems. Take Mount Elysium, for instance. Right now, it's a rocky, dry volcanic mound. But once rainy winds start showering the mountainside, we'll see an increase in erosion, the likes of which hasn't been seen on Mars in about 3 billion years. The last time we believe water flowed freely. Ice and snow will form, and new seasonal variations will herald even more changes, naturally sculpting the red planet. Even a small increase in atmospheric pressure will radically change what the planet looks like as it evolves alongside its new inhabitants. The north of Mars may be an adventure for our oceanologists, but the south is a geologist's dream, especially if you study impact craters. We're going to follow the coast now and get a better look. To the south are craters as far as the eye can see. This is a twin archipelago continent, with Hesperia to the east and Meridian to the west. Somewhere along the coast here will be the site of our first colony outside of Elysium. This will allow our scientists easy access to the thousands of impact craters that dot the mainland. Let's touch down here on the rim of this crater so you can have a better view. This is the border between Hesperia and Meridian, the Oenotria Canyons. Simulations project that this area of lowlands will experience large elevation changes. Escarpments will be carved into thousands of kilometers of smaller channels, which will be eroded away and smoothed by the sea over time. To the north, about 700 kilometers, is Isidis Bay, where the waters of the northern oceans lap away at the Oenotria lowlands, canyons and craters. To the south is the Hellas Sea, an inland body of water that's filled one of Mars's largest impact sites. Its diameter is about half the width of North America back on Earth. Water has already begun to wash away the north and south ends of the canyons. Depending on the geological activity from erosion, we expect this area to become fertile marshlands in the future. Allow me to show you on our view screen. Accessing predictive imaging for the Oenotria marshlands. Projected onto your view screen now is an image of what the marshlands could look like in the years to come. Here you see a new generation of humans on Mars, making their homes on the dark, ruddy high ground. What began as standard issue prefabricated shelters have been built up and expanded over time. These are people's homes, where they were born and where their children will be born. While humans will continue to arrive from Earth on new missions, these inhabitants will be the first planet-born Martian children. Hardy wetland grasses flutter in the Martian wind, and shrubs and trees have made the banks of this section of the channel much more resistant to erosion and flooding. Every morning, the people here climb down the stairs carved into the beautiful Martian rock to work the rice fields engineered across this span of shallow waters. The rice grown here will go on to feed settlements across the world. A number of fish have been introduced as the water has become healthy and potable, and boats ply the deeper waters. This is a scene of humans and nature forming a symbiotic relationship. Humans carefully cultivate and care for these new Martian plants and animals, which feed and even protect them in return. Over hundreds of generations, thanks to the difference in light, gravity, and environment, these Martians, the plants, and animals will evolve into something different, something distinctly of this planet. Now, let us continue our flight. Prepare for takeoff. We are now soaring over Meridian, the mountainous twin of Hesperia, marked by many small craters. Here, some years from now, large lakes will take the names of the craters in which they are formed. You may be asking yourself the reason for such a distinct difference between the northern and southern hemispheres. Geologists are excited to get their boots on the ground to truly study the hemispheric dichotomy. But there are already several theories. The prevailing theory is that most of these impacts happened during the primordial early bombardment phase, the formation of the solar system as we know it, about 4.5 billion years ago. At one point in Mars's history, the planet would have been much warmer and tectonically active. Lava flows could have smoothed down much of the northern hemisphere, leaving the other 2/3 of the planet much as it had been. The continent of Meridian ends here. We call this the Chrysae Inlet, located about halfway around the world from Elysium. There are several features that could make this one of the more interesting sections of Mars for settlement. Let me show you why. This is the Mariner's Valley, one of the most striking natural features of Mars, formed long before humans even walked the Earth. The valley stretches from the edge of Meridian in the east, all the way to the extraordinary plateaus and gargantuan mountains of the Tharsis continent to the west. The valley is 4,000 kilometers long and 7 kilometers deep. That's as long as North America and more than half as deep as the deepest part of Mariana Trench back on Earth. We believe it was formed by tectonic cracks when Mars was still a bit more of an active planet, geologically speaking. From the sky, Mariner's Valley looks like a giant scar on the surface of Mars. Closer up, the valley is an amazingly long system of canyons and caverns. Water is already pouring in from the oceans in the northern hemisphere through the inlet. As sea levels rise, much, if not all, of Mariner's Valley will be filled with water. This could be an incredible region, not only for habitation, but for exploration. Island chains will form out of the highlands and create a fertile river delta as water flows down from Tharsis through the canyons. As erosion and geological shifts from the terraforming process slow down, the canyons and cave systems will provide centuries of exploration for the cartology teams. There is even speculation that a dam could be constructed at the mouth of Mariner's Valley. At nearly 90 kilometers long, a dam of this size would be a massive undertaking. But then again, people once thought Mars could never support human colonies. And here you are today. A megastructure of that size could power the entire planet, which would make this region one of the more enticing to the developing Martian energy sector. That sector currently consists of a team of 12, so it may take a while for the solar system's largest human-made dam to be built. At the western end of the valley is one of the more interesting areas on Mars. It will be a fantastic introduction to the mysterious continent of Tharsis. We're currently hovering over what is called the noctilucent artist's labyrinthus, or labyrinth of the night. Calling it a labyrinth is apt. The cracked ground here is covered by jagged, maze-like canyons for miles, curving through the high plateau at the end of the southwestern portion of the valley. Even as the terraforming project continues, this area will likely remain important as a means of naturally delivering fresh water through Mariner's Valley. At this elevation, water will gather and freeze, with the lower portions of snow-capped mountains and perhaps even small glaciers melting during the warmer seasons, sending their runoff down through the valley. The Tharsis Plateau has some of the highest elevations on the planet, exceeded only by the volcanoes. The plateau is roughly 5 to 7 kilometers higher than what we consider sea level here. The rest of Tharsis is equally inhospitable. This is a continent of gargantuan mountains and ancient volcanoes that stretch to the skies. We're currently flying past the Tharsis Mountains, a set of 3 volcanoes that borders the plateau. And now we're approaching a dramatic sight. Mount Olympus is not only the largest, but the highest mountain in the whole solar system. Olympus is 2.5 times higher than Mount Everest above sea level. It's almost impossible to imagine the scale, even when you're looking at it. Like Mount Elysium, Olympus is wider than it is tall, sitting on its own plateau, higher than any other section of Tharsis, dwarfing the other mountains. The shadow cast by Mount Olympus's plateau alone could cover entire cities on Earth. Given the size and scope, the project has placed a moratorium on on-the-ground exploration of Mount Olympus for a staggering 500 years. The Olympus project will be busy enough establishing the base colony and initial scientific settlements. However, this area will be closely monitored, as the last thing anyone wants is a snowslide the size of many Earth mountains. However, this area will also change dramatically in the decades to come. You may turn your attention once more to the view screen. Accessing predictive imaging for Mount Olympus. Given the height of Mount Olympus, it is an obvious site for a space elevator, or planet-to-space transportation without the use of rockets. The elevator will consist of a cable counterweighted by a platform above the Martian atmosphere that will follow the planet's orbit. This will allow safe and easy travel into orbit and back again to the surface. Because of the relative difference in gravity, a space elevator is more feasible on Mars than on Earth, and would offer incredible opportunities for development. Once space travel technology advances enough, it may be possible to commute to work via the space elevator. You can imagine it now. You sip a coffee on the back porch of your home, overlooking the Hesperia coast. You hop on a transport ship that has you at the space elevator base in a matter of minutes. It then takes you into orbit, where you board an overnight ship to Earth. The next morning, you're enjoying a cup of coffee overlooking the Mediterranean Sea. The Olympus Project is here because of people like you. People who look up at the stars in the sky and wonder, what if? The first years on Mars will not be easy, but as we settle into our new home and learn more about it, our understanding of this world will pave the way for future generations to live in comfort. That understanding has brought us this far and will take us further than we could have ever imagined possible. Perhaps someday, future generations will look up at the stars in the Martian sky and wonder, what if? I hope you found this to be an informative flight over Mars. We're only a couple of thousand kilometers from the Olympus Project's colony at the base of Mount Elysium. As we follow the coast, where water is flowing for the first time in billions of years, I would once again like to welcome you to Mars, your new home. This is Asa, your autonomous suborbital assistant, signing off.